Professor James Lowenberg de Boer is the, I think it's your formal title is the Elizabeth Creek Professor of Data Technologies at Harper University in the UK, which is a university that specializes in digital agriculture and precision agriculture in the UK. James is well known to most of us as the president of the ISPA and also the editor of the journal Precision Agriculture. He has decades of experience in the US, in Europe, but also in Latin America and Africa, I believe, Jess, from which you can launch forth and give us some great insights on the economics of value creation from on-farm experimentation.
Thank you very much, Simon. Hello, I'm James Lowenberg de Boer, and I'd like to share with you some thoughts today about how on-farm experiments create value. We know that on-farm experiments have been going on for a long time. They've played an important role in the development and spread of farm and agricultural technology. We see there in the photo at the right, Henry Wallace, the founder of Pioneer Seeds, in a maize field with a farmer in the 1930s. On the left, we see some farmers and an ICRISAT researcher in a sorghum field, knowing that on-farm experimentation has played an important role in the development of technology in Africa and other parts of the developing world. But the question is, why do farmers and researchers and businesses bother with on-farm trials? Because they require time and investment. So the topics I would like to discuss are the role of on-farm experiments in making farm and agribusiness decisions, a little bit of a reminder on the economics of information, because on-farm experiments give us information. When are on-farm experiments worthwhile, and how to choose which on-farm experiments are worth doing. And the photo there on the right is just an example of my involvement in on-farm experimentation in Nigeria. So the role of on-farm experimentation is to test agricultural technology in real-world decisions and in real-world contexts. A lot of the focus, certainly in the literature, is on farm-level decisions, and it might be decisions about which crop to plant, hybrid and variety, genetic choices, planting geometry. Should it be twin row or skip row or row spacing, plant spacing in the row, fertilizer type, rate, method, application, pesticide product and rate, tillage type and timing. We shouldn't include livestock systems, so for instance, stocking rates might be or a focus of on-farm trials. And then it may go beyond the crop production part of the cycle and include storage methods and other aspects. But on-farm trials also do affect agribusiness decisions. So we might give examples of deciding whether to offer new products or services. Do those products or services really supply something that clients want? They might be used by an agribusiness to fine-tune the advice of farmers on seed, fertilizer, pesticides, other agronomic practices, and then helping them understand what can go wrong with ag technologies. On the research side, there's important role of on-farm experimentation in testing innovations coming out of research. what happens with those innovations when you put them in the hands of real people. They might also be a reality check on advice, extension advice, for instance, given to farmers on agronomic inputs. And there's a feedback loop, so it helps identify gaps in knowledge and technology that guide future research. In terms of the economics of on-farm experimentation, it's really a question of the value of information. And the value of information depends on the results from changing decisions. If information doesn't affect decisions, then there's a real question about whether it has value. And the key tool there is in evaluating the value of that information is the partial budget. So the value of information equals the revenue change because you've changed a decision minus the cost of implementing that change. So if you had to buy more seed or buy a different fertilizer or whatever it is, and then the cost of the information and analysis that gave you the information to make that decision. My observation is that most farmers are born experimenters, but historically most of their experiments were very informal because of the cost of information and analysis. They weren't trained to set up experiments, and also they have very limited time to devote to that. And as we'll talk about later, time is a crucial issue. The results of those informal experiments have a very limited inference space, and they may be misleading even on the farm where they were done. So a farmer may do an experiment with crop varieties and decide that one variety was the best in a given crop season. That doesn't mean it will be the best in subsequent seasons. And those informal experiments also can't be generalized by other farmers, agribusiness research. And so the amount of public good generated is very limited. For precision agriculture and information technology, the key implication is that those technologies reduce the cost of information and analysis, and so make on-farm experimentation more feasible. So just think of yield monitors, greatly reduce the cost of yield information to test a given crop technology. So if we think about the cost of information and analysis, so there may be data charges and subscription fees. So think of like a farmer buying a service that provides satellite images. There may be service fees for soil testing, drone fees. There may be equipment and hardware that are purchased or hired for the trial. Software, similarly, purchased or hired, training to use that software. There's the extra cost of analysis. And then a traditional cost of doing any kind of on-farm experimentation is just the extra labor required to lay out those trials and maintain them, and the opportunity cost of any time spent on those trials. So the figure here at the right is in the past a checkerboard trial of 7 seeding rates and 8 nitrogen rates would have required an army of technicians to implement. But the paper by Gardner, Mignot, and Bullock in Precision Agriculture in 2021 suggests that now requires some planning and expertise, but very little farmer in-field time. So it doesn't greatly delay either the planting or the harvesting operations. And the opportunity cost of farmer time can be quite high, and it can be especially high if that time is required at bottleneck periods. So Depending on the farming system, that might be planting, weeding time, harvest. And so Terry Griffin and other colleagues and I did some analysis using a farm linear programming model, looking at, okay, if a farmer took a certain amount of time out to do an on-farm trial, what would that potentially cost? And the figure here shows the combination of planting days absorbed, which is on the horizontal axis, and then each bar is in combination with how many harvest days were absorbed. So we see that, say, if it didn't affect planting time, but took a half a harvest day, we get a cost of $859 for the farm, and this is a whole farm cost. If it took 1 day planting and 1 day harvesting, we're talking about a cost of $7,266, which is important and doesn't include management time, which in fact may be the highest value part of a farmer's time. So the point here is that that opportunity cost of time can be very important. The cost of an on-farm experiment for an agribusiness can come from a variety of sources. Part of it is just the same as for research and businesses, is time and expense in doing it. Employee time and expertise is an important cost. There's also the issue of many business on-farm experiments have a technology promotion aspect, and farmers and researchers don't always come up with the right answer from the business point of view, if promotion is what's desired. And the example here in the figure at the right is some of the first on-farm trials with GPS-controlled variable rate fertilizer in DeKalb County, Indiana, in the early 1990s, showed that the profitability of VR fertilizer was small and unreliable. So the cumulative distributions of returns with whole field, grid, and soil type variable rate are intertwined. You can't really distinguish them very clearly. And that result has repeated itself in many on-farm trials of variable rate fertilizer after that. In this case, DeKalb Agra, the local co-op, was our partner in those trials, and they were happy to be able to give their co-op members good advice on what to expect out of applying this new technology. There's also the on-farm experimentation cost for researchers. There's the cost of devoting time to something that's difficult to publish. And so a lot of agricultural researchers are, their productivity is measured by refereed journal articles, and on-farm trials can be difficult to publish in refereed journals. Often that on-farm experiment data is messy. Things happen on farms. It's a much less controlled environment than experiment stations. And so it typically requires more time and effort for analysis. And just the cost of doing it. So the travel cost is an important cost. And in the developing world, because of poor roads, it often requires 4x4 vehicles. So you can see the Land Rover in the photo at the right, but even in industrialized countries. So when we did on-farm trials in Indiana, traveling across the state to check on on-farm trials was a major part of the cost of doing them. So how to choose which on-farm trials are worth doing? On-farm trials should focus on those which provide the highest net value of information. An important factor in determining the value of the information is durability. How long will that information be valid? Some agronomic questions are incredibly important for farmers, but they're also moving targets. For instance, hybrid and variety choice. And so the information is quickly obsolete. So in the US, the typical maize hybrid stays on the market about 3 years. So the farmer would need to be continually testing hybrids to fit his or her farm. Information about the effectiveness of infrastructure and equipment investments often have a longer useful life. So we can think there of maybe information about the value of under drainage or tillage questions, no-till versus conventional till question. So take-home message here. On-farm experiments create value by collecting information that changes decisions. The value of that information is typically estimated as the revenue change because of the change in decisions, minus the cost of implementing that change, and then minus the cost of acquiring the information and the analysis of that information. The opportunity cost of farmer, researcher, and business time and expertise is one of the biggest costs in implementing on-farm experiments. And we need to remember that farming systems are complex, and so on-farm experiments must be focused on those questions with the highest payoff. Thank you.